Chopin Framework is Next.js on-chain. So that's the front end, that's the back end, as a verifiable rollup. Everything on-chain, no compromises. Really cool idea. So I'm very excited to talk about Chopin Framework.
Yeah, thank you so much for having me. So the way that I would explain Chopin Framework is essentially it takes a rollup architecture, the same thing that allows you to do off-chain computation in order to scale a layer 1 blockchain. And it applies that architecture and that security model to a web application. So what we've really focused on is we've wanted to get a very nice developer experience. And so we focused on the leading front-end framework, Next.js. And what we've done is we've allowed developers to build applications using Next.js. And they can do it in the same, almost the exact same way that they would if they were building for Web 2. Except behind the scenes, Chopin Framework it essentially wraps the web app inside of a rollup framework. And by doing so, it gives the application blockchain security and interoperability. And it all does this while allowing the app to run in the web browser without requiring any extensions to be installed or third-party wallets. And it gives users also a Web 2 style experience if they want.
Mm-hmm. And so I guess we'll get into, first of all, why Next.js? Is there more languages? Just explain the choice on why fully integrating a Next.js as a rollup.
Yeah, so a lot of developers like to use Next.js. There's nothing specific about the underlying architecture we call it the Chopin architecture. The underlying architecture could be used to secure any type of application, including Ruby on Rails, including PHP, including any JavaScript framework that you like. All of this stuff is fundamentally compatible with Chopin Framework. But we focused on Next.js because that is one of the foremost adopted tools, and we want to just make that experience as smooth as possible. And what was the other part of the question?
Why Next.js specifically, and if there's any more other languages rather than just Next.js? So I think you covered it.
Yeah.
And so why is a rollup just like, why have all of Next.js, the front end, the back end, as a rollup versus using sort of just Next.js for a front end, or sort of typically have like a decentralized hosted front end, and then you have like a decentralized back end with like the crypto back end language, and like, you know, Next.js is just like normal Web 2, but maybe hosted on a sort of more decentralized hosted. So why fully as a framework? Why fully the front end and back end Next.js?
So part of this goes back to, if you know a little bit of blockchain history, essentially a long time ago, back when Ethereum was just getting started, there was a lot of questions around how it would scale. And there's this question of, do you do a layer 1 scaling or layer 2 scaling? And this idea for layer 2 scaling came about something called a rollup, where basically you're able to do a lot of computation off chain, and then you're able to, in a secure way, post the results and prove it to the network. And the cost of verifying that off-chain work was much cheaper than the actual cost of doing it. And this was a plan to allow blockchains to scale. Now, as people worked towards developing rollups, one thing that they realized is there's actually a profound flexibility that this gives to the developers to do things differently. So if you look at a lot of the new rollups today, Eclipse and Movement, these are all chains that have novel virtual machines, and these are compatible with an underlying L1 that is different than the L2. And so, for example, Eclipse uses the Solana C-level virtual machine on top of Ethereum, and it uses Celestia for DA. And Eclipse was able to develop this Solana adaptation without having to worry so much about the underlying implementations of Ethereum and Celestia. They were just able to plug in and use their technology and their preferred stack in order to build this. So now if you take all of this and you say, what can we do with it? And you take a step back. Instead of just trying to scale blockchains and make a better virtual machine, you think, what other things does this type of technology enable? One thing that you'll realize is that it also enables you to build arbitrary applications with arbitrary architecture. So there's nothing fundamentally different about Next.js than any other type of application, be it a blockchain application or not. It's still code. It still can be modeled as a series of transactions, an append-only log, and there's still basically a state transition function that updates the state, which is usually a database. And so we can actually map all of these Web 2 concepts to Web 3 concepts, and we can use the same rollup security model to enable it to enable a rollup to work, or sorry, a web application to work in the same way that a rollup works. And when you do this, you get all the same security properties that a rollup would get, and you also get interoperability with other blockchains, which is something that if you make a normal Web 2 app, you don't have. And so one of the, it is definitely possible, if you like Next.js, you could build your front end just in Next.js. And then you could, for example, do a Solidity smart contract, put it on an EVM chain, and you could use decentralized networks for hosting front ends and RPCs and stuff like that. That's all possible. But there's several problems with that. First of all, it is inefficient because what you're doing is you're essentially developing multiple applications using multiple protocols, and there's actually a lot of overlap there. So the Next.js application, the front end is in a sense going to be its own application. It's going to be a standalone application that is different from the smart contract. So now you have two code bases that you have to keep track of. And what you do is you then end up installing these libraries, these EVM libraries that build Ethereum transactions in the browser and then broadcast them over HTTP to the backend. And then you have all these questions about how do you deliver the front end? How do you deliver, what kind of RPC are you using? And all of these questions, first of all, it's hard to even navigate and make all these choices when you're building this app. And a lot of apps don't actually have decentralized infrastructure. But second of all, it's very redundant because instead of just building an application that has the logic that you want it to have, you're building two applications and you're trying to synchronize them. And you have a lot more tools that you have to keep track of instead of doing that. So what I would say to a developer who's used to building something with traditional smart contracts is consider how nice it would be. Let's abstract away what language you prefer and what framework you prefer. Maybe you like Solidity more than TypeScript, and Next.js doesn't sound that appealing to you. But consider this. First of all, you need a front end because users need to use your application. So you're going to have to, at least on some level, use some kind of full stack Web 2 framework to do this, to build your application. And you may not be doing a bunch of the backend stuff. Maybe you're going to put that on chain, but you're still going to be using this type of technology. There's no way around it. And the second thing you want to keep in mind is, isn't it just better instead of making a transaction and then broadcasting it to some RPC network and having that execute and dealing with a completely different on-chain system and manually writing the Solidity and all of that and basically adapting it so that it works in the browser? Wouldn't it just be better if you could just send an HTTP request instead of a transaction, and the server could just parse that HTTP request, because that is the native architecture of the web browser, and it's also the recommended architecture that is used to power REST APIs and things that could power your mobile apps. So when you use Chopin Framework, you're essentially able to use all the best tools that developers already use to build useful applications. And you don't have to also learn Solidity and also set up all this extra stuff and deal with all this extra tooling.
Mm-hmm. Could you talk about one of the benefits of this is less blockchain specific tooling, and then talk about the security assumptions of having the front end and the back end all as a rollup combined as one application?
Sorry, what was the first part of that question?
The specific tooling that is required if you want to use blockchain stuff, you have to use like a blockchain database. If you want to use like a front end, you have to use like, I guess this is less of a question and more of an observation. It's like, if you want to build a front end, it's like, are you building on Ethereum? Now you have to use, I think, like Ethers.js, or if you're using Solana, you have to use like a different framework, and they all have different wallets. I see one of the benefits of just having it all as Next.js, the front end and back end, is just like, you just like build the thing, use whatever tools that you want, and you're not bound to blockchain specific tools, which just have less development. Like it's way more niche to sort of try to go through these docs that a small team is building versus just like the Web 2 stuff, which is already there. It works perfectly. Like you just pick it up. That's one observation.
Yeah,
and then could you talk about the and then talk about the security implications of having it all in one stack?
Yeah. So one way I like to think about this is I like to go back in software history and look at the way that things have developed. So it used to be that programming was a very low level thing. So people would write stuff in C++, and they would develop these applications, and they would have all these problems. Like basically they would mismanage memory, and there would be memory leaks and seg faults and all these things. So when you use software, it would be a lot less reliable, and there would be a lot more security holes in that software. And that was just an artifact of where we were in terms of the software development as an industry. And over time, what happened as computers got faster, resource constraints lifted, programming got a lot easier. You got to move up a level of abstraction. So instead of, for example, manually allocating memory and managing it that way, we would have what's called the garbage collection, which would do that in an automated way. And so as a programmer, you could just think of very high level concepts, and you didn't really need to think about the resource constraints or manually managing the resources. You could just basically think about your application in the purest sense of like, what do I want to implement? And the tools would handle all of that important stuff for you. Now, all that stuff still happens under the hood, but when you're using like Python or JavaScript or Java or whatever, you are not, you're not thinking about it. You're just focusing on your code and your application and your use case. And so the way I like to put this is that this is like that same evolution for blockchains. So what Ethereum does is Ethereum, as an example, is an incredible decentralized network that synchronizes state across many different devices. And so everyone running a node is synchronized with this giant state machine. And you can write directly to this state machine using Solidity. This is like low level programming. And for some people that are building blockchain specific infrastructure, these Giga Chad, neckbeard kind of guys, this is something that they're always going to do. But for people who are focus on delivering value to customers, they should just be focused on building the app. They should not be focused on any of this memory management, low level stuff. And unfortunately, I think a lot of teams get bogged down on the difficult engineering requirements of using the EVM. And it makes sense because we've been in a resource constrained environment. So we've needed to make these smart contracts that are hyper optimized, and we needed to be very security conscious and all of this stuff. And because we couldn't do it in a more expensive way, we needed to focus on this because Ethereum has been slow. However, we are now scaling these systems. Ethereum is scaling. There's alt-DA layers. Ethereum's adding blobs. You can use Celestia. You can do sovereign rollups on Celestia. The ecosystem is scaling, and we're no longer subject to such scarce resources. So as a result, you can now have a sync engine that will translate the state of your application to a blockchain. And all of this stuff that you would normally be doing and optimizing in Solidity can actually be managed by a framework that handles it for you. And the framework is going to do it better. It'll be less efficient, but that efficiency loss won't matter because these systems are scaling so much. And so what I like to think about this is like this, you can make applications however you want. with Chopin Framework. In theory, you could still write Solidity. You could set it up to work like that. It's just the reason why I talk so much about Next.js is because I think that's what people want to use. And fundamentally, this is just alleviates the burden of people needing to do all this low-level blockchain engineering, and they can just use whatever tools are best for the job. And they use whatever tools, and they do it in whatever the way they want, and as long as it works, the framework will reconcile this with the blockchain, and it will do that all without you having to think about it.
Mm-hmm. I think the really like when you connect the idea of like C++ is like that's now Solidity, and now that like resource constrained environment where it's like absolutely needed, but like now we're like sort of in the abundance era where it's like you can really do whatever, and so
yeah.
I think that connection was really good.
Yeah, and I could also talk about the security, because you were also asking about the security trade-offs or considerations when you're building with Chopin Framework. So one thing, I think maybe what you were getting at was there is something very valuable about enshrining the entire stack into your protocol. So when most devs are designing their protocol, they're thinking only about the state machine and the security assumptions around the state machine. So they make these assumptions about liveness and about safety. And what this means is these are two facets of security that they like to think about. Safety is that the state is what you think it is, and nobody is going to fraudulently change it or trick you to, for example, if you have a certain balance, they wouldn't be able to change your balance, and they wouldn't be able to trick you to think that your balance is one thing when it's actually not. That falls under the category of safety. Now liveness is about making sure that the network is available to be accessed. So if the network can go down, there's a lot of things that you can do and to harm someone, and this is considered a vulnerability of the network. Now, both of these things, developers spend a lot of time thinking about, and they build their protocols so that they can always be available to the users and are verifiable and secure. But the problem is that is only for basically the state machine and essentially what you can think of as the back end of these protocols. And when you're actually using them, you're using an application that runs on your device. And so as a result of that, when the security people are thinking this is the greatest, this is such an amazing protocol, it's so well designed, look at all this amazing stuff, they're not thinking about the full stack experience of a given application that's being used. And it's very possible, and often the case, that a lot of blockchains, although the protocol and backend is highly secure, the application running on the device is not secure. The infrastructure that delivers the connection to the network, such as hosted RPC endpoints, that's often centralized. The way that the user comes and accesses the app in the first place could be downloading it from a trusted source, and that's another vulnerability. And all of these things are points of vulnerability that in reality affect the user, but in theory are not relevant to how you would analyze a protocol. So if you are serious about security for your users, what you really should do is you should enshrine the full stack and infrastructure of that application into the protocol. And by doing that, essentially you are allowing people to reason about the system as a whole. And that gives security analysts a much better toolkit. It doesn't automatically mean that you don't have vulnerabilities or your software is not centralized in some way. But what it does is it gives an analyst the toolkit to really reason about how your protocol will stand up in an adversarial environment.
Mm-hmm. And so I guess I want to talk about the more rollup part of things. So I guess a quick overview of the architecture, how Chopin Framework works in the background. You talk about how you can technically Next.js is just a choice that you've made just because it's really popular, but you could use other languages. I don't really understand sort of the back end of Chopin. So if you could just give me just explain the architecture.
Yeah. So Chopin is mostly optimized for the web browser. That's how I like to think about it. This is how I conceived of the idea, is thinking about it in the context of a web browser. So that's how I'm going to focus on it. Although there's other ways of thinking about it. You could use it for mobile apps and things that are not running in the web browser. But let's think about a web browser. Essentially what you do is you go onto a website. And so you go into this website, you type a URL, you click go, and then it takes you to a web page. So what just happened there? What happened is you resolved a domain, and then you connected to a remote server, and you sent what was called an HTTP request. And this is a GET request. This is what your browser does at any time you go to a page. It's called GET, G-E-T, GET request. So it sends a GET request to a server, and the server responds with whatever the server is programmed to respond with. So if you're on the front page of Reddit, it will give you the UI of Reddit, and it will give you the top stories across a variety of subreddits that's determined by the database that powers Reddit, or whatever type of system they use to store their data. It's not important. So then let's say that you're going and you're posting something on Reddit. Now we'll fast forward past the part where you are logging in, because that's a whole separate conversation. But let's say you're logged in, you go to Reddit, now you post something on Reddit. Now how usually that is implemented is you do another HTTP request, except this time instead of a GET request, you're doing a POST request. And so think of a POST request as something that's intended to mutate the state of the application. So when you're posting, you're creating a post, you're doing a POST request, and this is actually part of the HTTP protocol. And what you're doing is you're sending all of the content from your device to the backend. And that device is handled, that transmission is handled natively by the web browser. This is built into the web browser. It is a capability of connecting and making HTTP requests. And as part of that request, you will usually have some form of authentication. This can be tokens or cookies, and we won't get into all those details. But there's something that tells the backend that this was not just anybody posting this, this was you. So if I go and I say, hey, I'm going to post as Diego and say that I love Chopin, that would be not accepted. So the server would authenticate using whatever authentication method Reddit uses. Their server would authenticate that and reject that. But nevertheless, that would still be a post that was transmitted across the internet, a post request. So what we do is fundamentally, we treat post requests and other HTTP requests that are meant to mutate state as transitions. Oh, sorry, not as transitions, as transactions. And what we do is we use an embedded wallet to sign the body of those requests, and then we put it inside of the HTTP header. So if you go onto a Chopin-powered Reddit, what would happen is you would first go to the website, and by doing that, you would do a GET request to the server. And you could also think of this as the sequencer, if you are familiar with how rollups work. Now, a sequencer is basically just a server and that is responsible for building blocks of a rollup. And you can send RPC queries to a sequencer. So if you have a rollup, like an EVM rollup, and you wanted to know your balance, you could make an RPC request to check your balance to that sequencer. So this is the same concept. So you're going to chopinreddit.org, whatever, right? And you're making an HTTP GET request to the sequencer/server. And what this is doing is it will then read what's in the database, which is essentially the state of the rollup, and it will return to you it will not only return to you the data, the raw data that's in the rollup, but it will also give you a canonical user interface. So it shows how this data is to be interpreted. In other words, that's a long way of saying that it returns the UI and the page, and it renders in the browser. So that's how we're thinking about it. When you're doing a GET request, this is like a state query. And in the future, we don't have light nodes implemented, but in the future, the idea would be that light nodes would verify these queries so that you know you're getting the right data back from the server. And of course, light nodes are in development for basically almost all blockchains and all rollups right now. It's not the fact that we don't have light nodes. Like, you have to understand this is still under development, but it's also not like everyone else has light nodes. Like right now, there is some level of trust that is required when interacting with a lot of different rollups. But anyway, so you log in, you're querying state from the sequencer, and then you are posting. Now you're doing a HTTP post request. So what Chopin does is it intercepts that request, and it uses an embedded wallet, and this could either be an embedded wallet offered by our first party embedded wallet service, or it could be a external wallet that you have integrated with Chopin Framework, such as MetaMask or whatever the EVM wallet of your choice is. Either way, if you use our embedded wallet, you don't even have to approve it, but with other wallets you would. But you make this HTTP request, it signs the request, and then it transmits that to the server. So now, when the server receives that post, it will check the address and the signature, and it will make sure that it's valid, and that's how it authenticates who posted it. Now, there's one other piece of this that's very important. The data goes onto the blockchain. So I don't care who's querying the sequencer. Like, it doesn't really matter. Anyone can query it, just get whatever information you want. What's on the homepage, what's on this subreddit. That doesn't matter. That doesn't affect the state or consensus. Nobody will be upset if whatever you query, it's not going to change anything for anyone. But it does matter what you post. It matters that you, for example, sent some tokens from one user to another. That matters. So what we do is we don't log the state queries, we log the state mutations, and specifically the HTTP requests that create state mutations. And those are the post requests, and there's a few other HTTP methods that we log. So what we do is we have a log in order of all of the post requests, and this is the sequence of transactions that go to this rollup. So when you have a rollup, and let's say this is a rollup that uses Celestia, they're going to post batches or blocks of ordered transactions on Celestia. So what they have is basically a giant log of all the transactions that came into the rollup. That's how rollups normally work. So what we do is very similar. We have a list of all the a log of all of the HTTP post requests that came into the server. And this is the same thing as transactions. And each one of them has a signature of the user. So this is exactly the same thing as a transaction. What's cool is that you don't actually have to, like, normally people still use HTTP to transmit transactions to the RPC. But what they're doing is they're building a Ethereum transaction, and then they're wrapping it into an HTTP transaction. Essentially, that's what they're doing. And so this is just a much more direct way of communicating from a untrusted to a trusted, secure compute environment. And so the last thing I'll say about this is what this does is we intercept all the incoming post requests before they're sent to the server. We make sure that each one executes in a specific order so that the state is deterministic. And we take that ordered list and we put that onto a blockchain such as Celestia. That's how a rollup works, and that's how Chopin Framework works. Now, this would be considered a pessimistic sovereign rollup. And the reason is because it's pessimistic because we don't have light clients, and we don't settle optimistically to any blockchain yet. We're working on these things. So the way that you have full security is to run a full node. And a lot of blockchains are like this, but this is part of our security model right now at this stage. To have full security, you need to run a full node. That's why it's a pessimistic rollup. And it's a sovereign rollup because there's no enshrined bridge to another blockchain. So your sequencer determines the canonical state, or anyone running a full node will be able to see the canonical state of the chain. There's not another blockchain that has a smart contract that shows the canonical state of the blockchain. And so one of the big things that we're working on is interoperability, to actually allow other blockchains to verify the state inside the database of Chopin Framework applications and vice versa, to be able to securely query the state of other blockchains inside of a Chopin Framework app.
Mm-hmm. Really good overview. I think when you described the the request and then posts, like that's already in HTML, and then you have like the Ethereum transactions, they still have the same thing. It's like there's still an RPC, there still is like these you get like the Ethereum version of a transaction, and then you like stuff it through HTML, and then through those requests you still like have to like talk to an RPC and then get like, it's the same exact model of requesting data, so like reading state and then like adding new state, and so that's like a post. I think like that mapping onto Chopin just like makes a whole bunch of sense. I kind of just connected those ideas for me.
Exactly. And you don't need JavaScript for this. You could literally make an app that is 100% HTML and have an HTML form, create a Chopin transaction. This is truly using the web browser as a native execution environment.
Mm-hmm. And everyone has one, and you can just like connect it through the internet. And so really cool.
Yeah, it's installed on every device. And one thing I'll just also add, I think one of the big breakthroughs in making this really an amazing full stack experience is embedded wallets. Having the wallet in the browser combined with just executing it in a way that's native to the browser makes it just like Web 2. So like the only problem with this architecture without embedded wallets is that people would need to download MetaMask or Rainbow Wallet or whatever, and they would have to then use Wallet Connect and then approve the transactions through this Web3 flow, which is it's a good thing. I love that, and it's great when you're dealing with lots of money to have a very secure wallet solution and not to just necessarily trust an embedded wallet. But if you want mass adoption and you want users to have very low stakes when they're first interacting with their application, it's really nice to just allow them to just click around, fill out forms, click buttons, do the normal things they would do without installing anything first or setting anything up. And we use, formerly it was called Capsule, now they've rebranded to Para, and they are an embedded wallet, and they use MPC for custody. So they have a really good custody solution. So when you are using the embedded wallet built in the Chopin framework, you can rest assured that your key is not getting exposed to anyone. And when you take full custody of that key, if you decide to do so, that you're going to be completely secure. And you can go on their website and learn more about their security models and assumptions.
Yeah. I think it running inside all the browsers is just like normal internet stuff that just works. Like that is like consumer tech. Like you want people to like run it all themselves. You want sort of people to verify these proofs, these like clients. Yeah. Could you talk about, I guess the other parts of making it sort of a roll up with the determinism of the state, the like privacy problems, all of like that sort of blockchain stuff, which you have to convert that like Web 2 stuff into Web 3 compatible, verifiable.
Yeah, that's a good point. There's a lot of issues when you're that could arise when you're going from Web 2 to Web 3, especially if you're using Chopin Framework. So it's very easy and it's very nice, but there are things that you need to think about. So first of all, Chopin Framework is made for apps that are open source. So the assumption is that somebody is going to download the source code of your application and they're going to be able to run it as a full node. Now, of course, that's optional, and eventually we'll have light nodes, but but that has to at least be an option. So let's say that you're developing an app and you don't want to share that code with other people. It could be possible to do something and maybe make Chopin work for that, but that's not really what this is for. This is for open applications that are just like other blockchains where the source code is open, the state is open. This is something that's open and verifiable. Sometimes people want the database to be secret, and there are privacy solutions that can be built for Chopin apps, just like there could be privacy solutions for any rollups. But also, just like the situation with most rollups, privacy is a lot less mature, and so we are not ready to have like fully private Chopin apps. Definitely, like if this is something that's interesting to you, reach out to me. I have ideas on how to build this, but right now, like this is for open apps. So social networks are great things where people put public comments, but DMs, you would at least want to implement some sort of end-to-end encryption, and you may or may not even want to put those messages on chain. So there's certain types of apps that deal with sensitive information, which maybe the blockchain is not really a great source of. It's not a great way of building those. Does that answer your question?
Yes. I also want to talk about sort of, I guess you already covered it, where it's Chopin is more of HTTP, like as a rollup, and then you get to like run anything that's already runs inside the browser. So like JavaScript, Next.js inside of a rollup. Mm-hmm. I guess now I want to talk about sort of how you came to this conclusion, sort of just like, we sort of just like got right into it and forgot the intro. Yeah. So like who you are, why Chopin, how you got into it, all that.
Yeah, so I was pretty early to building in the Celestia ecosystem. And originally I was building a block explorer for modular blockchains. And the idea was that like Etherscan, for example, existed for Ethereum, but there's a lot of different assumptions that underlie what is needed to service the Ethereum ecosystem. And when Celestia was coming out, it became apparent that there's not just going to be one blockchain that mattered. There's actually going to be thousands or tens of thousands of rollups, and each of them are their own blockchains, and each blockchain has its own unique implementation. And so as a result, the infrastructure that would need to support that was going to be it needed to be rethought. We needed to build a system that handled a lot more scale, a lot more data, and a lot more diversity of chain implementations. So that's what I set out to build, and I think we did a really great job building the modular cloud explorer, which had over 1,000 different integrations with various rollups and settlement layers and DA layers and execution layers, and it was cool. But one of the issues that I found is that when you start trying to build tools for blockchains in general, especially as you start to generalize across multiple blockchains, the larger the set of things that you are servicing, the more general the abstractions have to be, and the harder it is to create abstractions. And at the limit, I could kind of see the writing on the wall here. At the limit, as this ecosystem develops, you end up building, like, let's say, like a GraphQL data service for blockchains, or maybe like some like SQL streaming service for blockchains. Like you end up making all these tools for blockchains, and really at the end of the day, it's just a very thin wrapper around some existing tool that serves that's actually more powerful outside the context of blockchain. So what you end up doing is you end up creating all these tools, quote unquote, for blockchains, and it's just a worse version of the tools in the first place. And what would be really great is if people could just build applications using the technology that they already like to use, the ones that are validated in the market to build, the ones that people already use to build useful applications like Next.js and Postgres and all of these things. And of course, this was not always possible. But now we're getting to a level of abundance in the blockchain space where it actually is possible to verify these types of things on chain. And so as a result, it makes sense to build a solution to allow people to just use whatever tools they want. And for example, if you want data visualization, don't use a blockchain data visualization tool, use a data visualization tool. What's the best one? Use that. Think of yourself as an engineer that's solving a problem just like everyone else in Web 2. And you shouldn't have to be thinking about all this low level blockchain stuff. That should just be handled automatically.
Mm-hmm. Great. And then talk about so I guess you were really frustrated sort of having this integration problem of just like having to adapt all these weird blockchain niche languages into one modular explorer. And so I guess that was like the breaking point where you were just like, I don't want to like play integrations all day long. I like want to like actually build something.
Yeah.
You just talk about the transition from modular cloud to Chopin.
Yeah, I mean, I think you hit the nail on the head. There's two trends that are going on. One is that there are an increasing number of chains that are being built in different ways. So now, like if everything was an EVM chain, that would be one thing. You could make a lot of EVM specific features that would generalize across all chains. Now, unfortunately, there's also SVM and MoveVM and all these other types of ways of building these chains. And more different ways of building chains and unique quirks are being added every single day. So whenever you try to make one abstraction that generalizes across all of these different chains, in a sense, that gets harder and harder because there's less assumptions that you can make for each chain. And then the other trend is like basically the overall trend is that things are getting hyper specialized. So what people are starting to do is instead of building a general VM rollup, what they're starting to do is they're starting to build application specific rollups. So now what people want is not just it's an EVM block explorer. They want an application specific block explorer. So really if you're to build a block explorer for this modular future, since people want application specific block explorers, essentially in order to build that for the whole market, you have to basically build a general tool that will visualize data from a general set of applications. Like the degree to which this is blockchain specific starts to fade because of the extreme diversification with the application specific chain thesis. And this is really the direction things are going, and this is what people were asking for. So in a sense, like you can kind of see how you kind of end up building a tool that's just a general data visualizer tool that happens to work with blockchains. And at the same time, I was very close to all these teams building rollups. And I saw that people were basically taking an EVM or some other established blockchain like SVM or something, and then they were kind of taking it was normally an L1, and then they were porting it over to be for L2s. And they would, like increasingly improve the developer experience of making L2s. They would do like one-click deployments and all these really cool things. But the problem with that is that they were like approaching this end goal, which is basically abstracting away the blockchain, thinking about it as a blockchain. But the starting point that they were coming from was from existing blockchains. So they're like walking in this direction. But what I saw was clear writing on the wall that none of this was necessary. We don't need to build your app on top of an EVM fork. We can actually just build your app the way that you normally would build it, and then basically build something that will then settle it to an EVM or bridge it to an EVM. You don't actually need to start developing it from the base. The framework itself doesn't need to be built on top of the EVM. And so I think that this is ultimately where things are going. But I saw that this is just something that nobody was building, and it was just a very obvious. It was to me very obvious that this is how we should build apps using modular infrastructure.
Could you talk about the sort of demographic or sort of type of developer who would use Chopin? Because I'm pretty sure like an EVM dev or like an SVM dev doesn't really like this is not like for them. Who is Chopin for?
Yeah, that's a great point. I think I'll first say about who it's not for, because I think it's everybody else's who it's for. So it's not for developers who have very specific blockchain, very specific objectives of things that they want to build, and that's like a blockchain infrastructure that needs to be hyper optimized. So finance applications and protocols that need to be maximally efficient and stuff like that. These still should be built in the same way that they always are. And the reason is because they think about nowadays, people are still writing C++. Like if you look at like high frequency trading firms and stuff, they're still writing C++. Most application developers don't, but some people still do. People working on operating systems, they sometimes might do C++. And so there's a use for that. So these people who have these very specific goals, these very talented engineers that know exactly what they're doing, they should always write blockchain native code. They shouldn't use Chopin Framework, because their goal is not to make an application. And if you really know what you're doing, like you really know, and you know that you're trying to get all the performance humanly possible out of this one application that you think was barely going to work unless you can squeeze all the performance out of it, then again, maybe not the best thing, because you're working at a different level of abstraction. But for 99% of people building consumer applications, not blockchain infrastructure, this is a better way of doing it. You shouldn't think about that stuff. You're more likely to mess it up. Just like you're more likely to mess up memory management than a garbage collector. And sometimes that can get you in trouble, though. The garbage collector, if you really know what you're doing, you don't actually want that. But most people don't want to think about that. It's a waste of their time and resources. They're way better off. It's not that they can't do it and like they're dumb. It's that it would be dumb to waste your time on something that's automated when you are not resource constrained. And then one thing I will say is there is an extent to which, in general, DeFi is maybe not the best suited for Chopin Framework. And I'm not saying this in an absolute sense. I think it depends. But there's certain things that in finance that are really well covered already by current existing blockchains. Like all these like AMMs and DEXs and all these things that exist that people use, these are already proven to work in existing virtual machines. And so if you were to reinvent this in Chopin, you could do it, but why are you not forking and building off of the prior work that already exists? I think might be a good idea, because these things are validated and they already work in this other context. So there may not be a reason to reinvent the wheel in Chopin. And the other thing I will say is that fundamentally, we're kind of getting to a different world in terms of blockchain development. And so previously, a lot of blockchains have optimized for computational speed. And so the constraint has been, you have this smart contract and it has to execute all these steps inside of the contract, and the node was just too slow to handle the scale of the amount of computations that are needed. And now, though, so the reason why that was an important thing is because finance is very computationally heavy. There's a lot of computation that happens in financial applications as opposed to other things like utilizing bandwidth. So the ratio of compute to bandwidth in these systems is very different. Let me try to explain why. If I transfer you a certain amount of tokens, and then you transfer it back, and I transfer it to you, and you transfer it back, and I transfer it to you, and we keep doing this, back and forth a bunch of times. At the end of the day, we're going to have a very small state. We're just going to have either your balance and my balance, and those balances are going to be like single numbers. So the state, even if we're just sending between ourselves, the state that is calculated by the chain is going to be very compressed. And so that, and fundamentally, that is the thing that people are trying to verify, is your current balance. That's the thing that people are trying to verify. So it's actually very easy to service such an application, but if you want to have a high throughput, you need to have a lot of compute to actually calculate this. Now, with Chopin-based apps, there's a lot more bandwidth needed for state queries. And so instead, like what happens is you do mostly CRUD operations. So like, let's say you wanted to make a web app like Twitter or something, or X.com as we call it, right? You're going to be creating a lot of transactions, and the ratio of compute to bandwidth is going to be very different. So you're going to not do much compute. You're just storing some value, but you're going to be sending these long tweets, and you're going to be getting lists of people that you follow, and you're going to be like querying lots of things. Or maybe YouTube is a great example. There's not a lot of compute that's happening on YouTube. They're just storing this video in the database, but there's tons of gigabytes of data per video that has to be posted and then is now in the state and has to be returned to the user. And so, as you can see, like the amount to which data gets compressed in that context is very different. Like basically, finance applications run a reduce on all of, like they basically reduce all the transactions into a few numbers, whereas most applications that people actually use don't do that. And so blockchains are very optimized for that finance use case, where the end state is highly compressed relative to the amount of transactions. I think that in the future, we're going to have a lot of applications that are not like that. So as a rule of thumb, I would say if something fits really well in that mental model of finance, where you're doing a lot of transactions and the state is not growing very much, it's still a very compressed state, this is something that is a high compute, low data app, low throughput app. And I would say that is good for regular smart contracts, and everything else is better for Chopin Framework.
Mm-hmm. Like really, really good overview of just like understanding sort of the old primitives, like why we built blockchains, and then sort of why they sort of hurt us for these more consumer apps. I think like I was like, oh wow, like it's really good. Another question is, why the name Chopin?
Haha, good question. So this was originally, I just wanted to basically drop in this thing and drop in this library and make a Next.js a blockchain, or go on the blockchain. So it's blockchain drop-in. And in my head, I was saying this is a blockchain drop-in for Next.js, and chain and then drop-in, op-in, Chopin. And I'm like, oh, Chopin. It's a composer. I like classical music. Sounds good. So that's why.
Mm-hmm. I always love like those like background. They really tell you like a lot of just like what's the like they just like some names just encapsulate sort of projects. So I always ask that question.
Yeah.
Is there anything else that I'm missing? I feel like we had a good overview.
I have to go in 5 minutes, but I'll say like one more thing. Let me think. How do I?
Or if not, we can just wrap it up.
Oh, no, one more thing I wanted to say though was about Celestia, or just DA layers in general.
Okay.
How do I say this? I'm thinking maybe just cut this out if it's not good, but I'll just say it. So like one thing that I like to think about for DA layers is that they are essentially scaling the primary bottleneck in the long term for blockchains. So there's two primary constraints on a blockchain. One is bandwidth, and the other is compute. And compute also encapsulates memory and all of these things. And we know that fundamentally, these systems have different scaling laws. So compute scales with Moore's law, and bandwidth scales with, it depends on exactly how you measure bandwidth, but it scales with, at best, most optimistically, it scales with Nielsen's law. And so fundamentally, as we go through time, we are going to basically have an abundance of compute relative to bandwidth. And so that's why it's important to keep this in mind when you are looking at which blockchain has the most scalable architecture, because the constraint in the long run is going to be bandwidth, because compute scales exponentially relative to the degree to which bandwidth scales. So like if you fast forward many years, we're going to have way more compute than we have today, and we're going to have a lot more bandwidth, but not as much. So over time, we're guaranteed to be bottlenecked on a long enough time horizon by the data that can be throughput through a system. So I think it's really cool that DA layers now, like Celestia, are focusing on scaling bandwidth by abandoning compute. They don't even try to do compute, because that actually bottlenecks their ability to scale DA and bandwidth. And so if you think about how Chopin Framework works, the HTTP requests are transactions, and these transactions are being transmitted over the internet. And the way I like to think about Celestia is like, Celestia is like a verifiable internet connection that connects, that basically, since the sequencer talks to Celestia, it's essentially all requests are going through Celestia to some extent. And so what I like to think about this is like, this is like verifiable broadband, and as Celestia scales to gigabits, and hopefully I'm hoping we can get to terabits per second of throughput, we're going to basically be able to enable almost anything you could ever imagine. If you look up the amount of bandwidth that a small data center or cloud has, it's like a terabit per second or more. So if Celestia can get to that, we could basically build whatever we want. Anything could be a DApp, and anything could be verifiable.
Insanely like amazing idea. Like I think that with you describe execution as like the focus for like the finance blockchains, but now like Celestia is doing the inverse, and like now, anyways, insane idea. We got to wrap it up. Call to action. Anyone who wants to use Chopin, what should they do? Who should they follow?
Follow Chopin Framework on X, and you can go to Chopin, CHOPIN.sh.
Anyways, thank you so much, Liam. Great episode.
Thank you.
Love like very cool ideas. Anyways, thank you.
Thank you so much. I really appreciate you having me.